In this program, we'll use a button and a variable to control the color of the entire LED strip. Anytime we're using the LED strip, we want to include the LED strip.h library. A library gives your code access to special functions that for us apply specifically to some hardware. For example, when we have the LED strip library, we can use the setPixel, draw, and clear functions in our code. We also need to name our LED strip. I name mine strip, and we need to complete the LED strip function. It has three arguments. First, the number of pixels that are on the LED strip. Second, which pin of MakerBoard is plugged in to the green wire of the LED strip. And third, which pin on MakerBoard is connected to the blue wire of the LED strip. We also need a variable for this program. To create a variable, we'll first determine its type. I want to use an integer variable, which is shortened to int, and an integer variable will always be a whole number with no decimals. Next, we'll name the variable. I'm naming this variable color because that's what it's going to stand in for. This variable will replace a color value for the LED strip. Next, we use an equal sign and give the variable a starting value. So I want color to start at 0. So we have an integer called color with a starting value of 0. In the void setup function, we'll use the pin mode function with arguments to and input pullup to set up a button. When a button is set up as an input pullup, when it's pressed, it sends a low signal into the code. Within the void loop function, we use the setPixel function to determine what color and which pixels are lit that color on the strip. SetPixel has two arguments. First, which pixel or pixels we want to light up. We're using strip.all to tell the LED strip to light up every pixel we have. The second argument is a color value. In the past, this color value has been a number that is ranged from 0 to 299. So we would insert a number there, and that's what color our LED strip would show. Now, we want to replace that number value with a variable value. So we put color in there, and the first time the void loop runs, color will be equal to 0, and that's what color we'll see on our entire LED strip. The next function is strip.draw, and that sends the setPixel data out to the LED strip and displays it. Next, we have an if statement, and the if statement has two main parts. Between the parentheses of an if statement is a condition that gets checked every time the if statement runs. Between the curly braces of the if statement are the actions that run when the condition is true. In this case, we're taking a digital reading from port 2, and if that digital reading is low, we want the actions of this if statement to run. If the button on port 2 is pressed, then we want the code inside the curly braces to run. The first thing that will happen is color plus plus. Plus plus adds 1 to the value of the color variable. So if color was 0 and this if statement condition was true, when this line of code runs, color becomes 1. Next, we have a delay of 100 milliseconds, and this delay controls how fast the color of the LED strip can change. If you had no delay at all, the strip would change really fast, and if you have a larger delay, the color of the strip will change more slowly. Next, we have another if statement. This if is checking the value of the color variable. The condition here is color equal to 299? If that's true, the code inside the curly braces will run, which resets the color variable to 0. We know that we only have a range of colors on the LED strip from 0 to 299. So as color increases through the color plus plus command, once it reaches its maximum value, we want to reset it to 0 and let our colors start over again. Once the code reaches the end of the void loop with this closing curly brace, it jumps back up to the top of the void loop and uses the setPixel function to set the entire strip to whatever value the color variable is now. So let's see how this would work. If color starts at 0, then we're going to see a color value of 0 on the entire LED strip. If you press down on button 2, then this condition of the first if statement is true, color becomes 1, and after a delay of 100 milliseconds, the code drops down to check the condition of this second if statement. Color equals 1, so that's not 299. The actions of the second if statement are skipped, the code reaches the end of the void loop and jumps back up. Now it's going to set the entire strip to a color value of 1 and draw that. If you're still holding down on button 2, color will increase again, delay 100 milliseconds. Because color is now 2, it's still not 299. The second if statement actions are skipped, the void loop completes, and it jumps back up. So the color is going to slowly and continuously change as long as you're holding down on button 2. And once that color value reaches 299, it should snap back over to 0, allowing you to go through the whole range of colors again.